Hello, welcome to the introduction to the reinforced concrete beam design per ACI 31808. And in this implementation, it's an Excel spreadsheet, and compact sections is embedded into that spreadsheet and then coded with Visual Basic. So the objectives are first off to show you where to find the spreadsheet in the installation. And then we'll walk through how to use the spreadsheet, that is, put in the inputs and get the results out. And then we're going to walk through the code, and it's about 15 minutes in each one of these parts. We're not going to go into the details of the method because we want to keep these videos short. But if you do want to know, if you do need a refresher, you can see civilpe.net. And we've used some of the examples that are in those videos as checks. So, and some of the variables line up with what they used. So the goal is to get you to the point that you could take this spreadsheet and modify it to other ACI methods. And hopefully that's what we get done. I thought I'd just take a minute and show you how exactly you get to the videos for the reinforced concrete beam. So I've gone to civilpe.net and it's right here. And in there you'll see a walkthrough of a rectangular and T-beams. So now let's go to the spreadsheet and open it up and start walking through the inputs. So first off, let's show you how to find it. And you would find it underneath Program Files, x86, Structures Office, Compact Sections, and Documents. And it's this document right here. And you want to make a copy of it, so you know, if you mess with it, you can always go back and get to the one that's working. So the spreadsheet is divided up into 3 tabs. One for rectangular beams, and then for T-beams, and then materials. And here we define the rebar geometry and area. Your concrete materials. And if you wanted to add one, you just give a name, your compression yield, and your strain, max strain. Here's steel for the rebar. Again, you just give a name, Young's modulus, and the yield and tension. And this column over here is just used for some of the pull downs, and I'll talk about that in a minute. So let's go back to the rectangular beam. So the goal here is to compute the moment and shear capacity. The assumptions is that positive moments create compression. Plane sections remain plane. The tensile strength of the concrete is neglected. The concrete is not lightweight, which means lambda in the calculation for VC is 1. Compression strength of the steel is ignored. And the maximum compressive strain is 0.003. Then over here is the inputs for the concrete block, the width, the height, and the edge distance. Edge distance is the distance from the edge of the block to the outside edge of the stirrup. Then the top bars, how many bars across the top. In this implementation, there's only one row. And then the rebar that you're going to use. And you can select that. I'll show you how this is wired up in a minute. The bottom bars, you're allowed 2 rows. You choose your rebar and the number of bars in each row. In this case, there's 4 bars across in each row. The stirrups, again, you do your selection of the bar and then the spacing along the beam every 12 inches. Then the materials that we're going to use for concrete, we're going to use this, and we've got two options because that's what we defined in the materials tab. And steel, we only have one option that we set up. Then a design moment, and then the program will calculate the required steel and if you have an adequate amount. This is where its program is executed when you click Build and Analyze. And then the results down here will be your moment capacity in kip feet and shear capacity in kips. Now, if you're wondering how, I'm not assuming you're an Excel expert, so if you want to see how that's done, we're here and you'll have to get this developer tab turned on. Go into design mode. Right click on, say this pull down here, and look at the properties. And over there you'll see that the bound column is 1 and that we're using the fill range is called Rebar database. And if we go over here, go to formulas, see name manager, we'll see the various ranges that are defined. So to wire up a pull down, you would give the list fill range and which column in that range you're using. And you notice down here is a check against one of the video examples. And it says that the moment capacity should be 124.6 kip feet and shear capacity should be 62.6 kips. When you have one row of rebar at number 6, and we're talking about the bottom bars, and stirrups at using number 4 at 12 inches, and the concrete would be the 6,000 psi. Width is 12, depth 24, which is what we have right now. Edge distance 1.5, and E of the steel is 29 e to the 6, which is what the common steel is. So let's do a check here. One row, the bottom bars, number 6, 3. So we got 3 already. Let's change that to number 6. And then the number of rows, 1 row, and let's run it. And we see we do have 124.6 kips, and the shear capacity is 62.6. Now let's walk through the T-beam spreadsheet. The assumptions are the same as for the rectangular beam. Your geometry for the T is right here. You have the width of the flange and the depth. One flange is this part up here. Width and depth of the depth of the beam, which is from here down to here. The width of the web, this part here is the web, so this is the width. The edge distance is the same as before. It's the distance from here to the outside of that stirrup. And the concrete property for these, the flange and the web. The top bars, bottom bars, stirrups are the same. So it's the same interface, just a little bit different geometry. And down here is our checker. So as you're going through and you're modifying the code, you might want to, have a test case that you can always go back to and make sure that everything is still working. So in this case, it should be, let's see, 125.6 for one row. Okay, for one row, let's change number of rows to 1. dealing with number 6. 3 bars, 4,000 pound PSI. Let's run it. And we got the 125.6. And for 2 rows, using number 9. So let's go to 2 rows. Two rows of number 9, 6 bars, so there's 3 across, and run it. We got 493. So that's the overview of the spreadsheet, and in the next video we're going to go through how this was coded up.